So far, we talked about different types of functions, like if you have a constant function, if f of x is equal to c, and we saw that the derivative of the function is equal to 0. If you have power function, like x to power n, the derivative of the function is n times x to power n minus 1. Well, we have other functions, am I right? Exponential functions, logarithmic functions, and so on. Sine function, cosine function. The question is, if you have the addition of two functions, how do you find the derivative? If you have addition of two functions, you can separate those two functions and take the derivative one by one and then add them together. The same with difference between two functions. So here, f plus g prime is f prime plus g prime. And if you have difference between two functions, the process is the same. You can take the derivative of first function, take the derivative of second function, and then do the subtraction. Take a look at this polynomial. So here I have a polynomial including x to power 8, 12x to power 5 minus 4x to power 4 plus 10x cubed minus 6x plus 5. So I can take the derivative of each one of these terms separately and then combine them together. Or directly you can use the derivative and take the derivative of each one of these separately. So the derivative of x to power 8 following the power rule is going to be 8 x to power 8 minus 1. The second one is 12 x to power 5. So plus 12 times 5 x to power 5 minus 1. The next term, as we see here, is negative 4 x to power 4. So you get minus 4 times 4 x to power 4 minus 1. The next term here is 10 x cubed. So you get plus 10 times 3 x to power 3 minus 1. Then you have minus 6x. The derivative of negative 6x is minus 6x to power 1 minus 1. And finally, the last term is just a constant, right? So when you have a constant, the derivative of the constant is basically 0 plus 0, because this is just a constant function. As you remember, when we have a constant function, the derivative of constant function is 0. The rate of change of the constant function as a horizontal line is 0. So let us simplify this. You get 8x to power 7 and plus 60x to power 4 minus 16x to power 3 plus 30x squared minus 6. And that's it. So this is the final answer. This is what we're looking for. It's a combination of addition, subtraction of different functions, and as simple as that, you take the derivative. We can make it more interesting. For example, we're interested in finding the points on the curve of this polynomial where the tangent line is horizontal. So when we say tangent line is horizontal, what's the meaning of that? It means that slope of the line must be equal to 0. It means that the derivative of the function at those values must be equal to 0. So let us find the derivative of the function, set it equal to 0, and find those values. Here we have the graph. By the graph, we know that we have 3 points where the tangent line is horizontal. So we expect to get 3 points. F prime, or y prime in this case, is equal to 4x to power 3 minus 12x plus 0. And we are looking for the values. Where f prime becomes 0. Okay, I need to take 4x cubed minus 12x and set it equal to 0. By factoring, this can be written as 4 times x squared minus 3 equal to 0. Basically here, I factor out 4 times x. So how do I solve this equation? To solve this equation, you set 4x equal to 0 x becomes 0. You said x squared minus 3 equal to 0. X squared is 3. So you end up with two solutions here. X becomes plus and minus square root of 3. So including 0, we have 3 solutions. So the tangent line is horizontal at 3 different points. Well, to find the y values, we can plug these back into the function and find the y values. For example, when x is equal to 0, your y becomes 4. When x is equal to square root of 3, your y is negative 5. When x is equal to negative square root of 3, your y is negative 5. So we found the points where the tangent is horizontal. You just need to take the derivative of the function and set it equal to 0 and solve for those x values. So again, your function f of x is equal to x to power 4 minus 6x squared plus 4. F of 0, one of the values 0 is here, is 0 to power 4 minus 6 times 0 to power 2 plus 4, which is 4. This is this point here. If you plug in square root of 3, you get square root of 3 to power 4 minus 6 times square root of 3 to power 2 plus 4. Well, square root of 3 to power 4, it means that you are multiplying a square root of 3 4 times by itself. So you have 3 times 3, which is 9. 9 minus 18 plus 4. Here you can simplify this. You get 9 minus 18, which is negative 9, plus 4, which becomes negative 5. With the same calculation, f of negative square root of 3 is negative 5 as well. So we have 3 points where the tangent line is horizontal.